In this video, you're going to learn how to graph a quadratic that is in vertex form. Vertex form is y equals a times x minus h quantity squared plus k. With vertex form, you have three constants you need to look at to help you graph. A, h, and k all have different effects on the graph. H, for example, is a left and right movement of the parabola. So h is positive, it moves right. H is negative, it moves left. K is the up and down movement. So if k is positive, it goes up. K is negative, it goes down. The a value does a few things. Number one, if it is negative, that means it's reflected downwards. If a is bigger than 1, that means it's vertically stretched. So it gets skinnier or narrower. And if a is in between 0 and 1, we call that vertical, call it compression, shrinking, either one. But it kind of squashes it downwards. It makes it a little wider parabola. So when you're looking at a vertex function, vertex form of a quadratic function, think about these three letters and how it's going to change the graph. Looking at number 1 here, you have y equals quantity x plus 4 squared minus 2. It might be helpful to rewrite the basic format of vertex form to help you determine what h and k are. Now, inside we have x plus 4, and inside the red writing we have x minus h. So I'm going to rewrite this using subtraction so it's a little bit easier to see what h is. If I have an addition of two numbers, I can rewrite that as the subtraction of the negative number. So x plus 4 is the exact same thing as x minus negative 4. Now, why would I do that? Well, if I just highlight h and notice that there's an x minus in front of it, I go down here, I see x minus in blue. That means that h has to be negative 4. Now, h being negative 4 kind of contradicts what you see here where it says x plus 4. And that is due to the fact that the vertex form is x minus h and not x plus h. This is the reason why I have you guys rewrite it in terms of subtraction. Now here, the minus 2, you have plus k. So we're going to rewrite this using addition. So minus 2 is the same thing as plus a negative 2. So we have plus k. I'm going to highlight just the k. Look for the plus sign here and highlight what k is. K is negative 2. So therefore your vertex, the whole reason we call it vertex form, is negative 4, negative 2. So that's the lowest minimum of our function, the bottom of our U-shaped graph. Now in order to find other points, we're going to make a table, an x, y, t table, and we're going to put the vertex smack dab in the middle because it is symmetrical around this point. We're going to use the x values above and below negative 4. So below negative 4, negative 5, negative 6. Above negative 4, negative 3, negative 2. To find these other y values, you have to plug in each x value, negative 6, negative 5, negative 3, negative 2, to find the corresponding y values into the function. So starting with 6, I'll change colors here for calculating. So copy down the exact same function except you're going to replace x up here with each number. So this first one's negative 6 plus 4 quantity squared minus 2. Using your order of operations knowledge, do what's inside the parentheses first. So negative 6 plus 4 is negative 2. Negative 2 quantity squared is 4. And 4 minus 2 is 2. So that first y value is 2. Calculate for -5. Y equals, parentheses, -5 plus 4 squared minus 2. Parentheses again, -5 plus 4 is -1 squared minus 2. -1 squared quantity is 1. And 1 minus 2 is -1. This next point, -3, y equals -3 plus 4, quantity squared, minus 2. -3 plus 4 is 1. 1 squared is 1. And 1 minus 2 is -1. You'll notice how they start to repeat themselves. And that's what gives you the U shape. So if this for -3 is -1, that's because the one before the vertex is also -1. You can do the same thing for these 2 points as well. So if you were to calculate that, you would get 2. You can confirm that in case you're unsure if your first point's correct. But if you know your first point's correct, you can kind of just copy them down and make the table symmetrical, much like the graph. Graphing the points, -6, 2, -5, 1. Sorry, -5, -1. -5, -1. -4, -2. -3, -1. And -2, 2. So you see how the repeating y values gives you that symmetrical shape. So these 2 in yellow and these 2 in yellow, those are these 2 points here. And because they have the same y values, it gives you that U shape. Okay. As you can see from the graph, it's been transferred left and down. So if I want to do the transformations for this graph, transformations are going to be how did it move left or right? Did it get reflected? Did it get stretched? It moved left 4 and down 2. And actually you get that from the vertex. -4, -2. It has not been reflected and it has not been stretched because a value is +1. Now as far as domain and range goes, domain, it goes left and right forever, -infinity to +infinity. It hits all the x values. Range, your y values, does it go down forever, does it go up forever? Those are the questions you got to ask yourself. Well, on this graph you can see it kind of bottoms out there. That's the lowest point possible. So -2 is your lowest point. These arrows go off up forever, so it goes on to +infinity. And that's your range. The last thing, zeros, where does it cross the x-axis at? Well, it crosses the x-axis at about there and there. So we can kind of estimate it to be -5.5 and -2.5. They're not exact, so x is zeros are possibly -2.5 and -5.5. Now, some of your points might actually be the zeros, so go ahead and write those down if they're exact. But if they're estimated, put the squiggly line and round it. And that's your graphed function with all the given information for transformations, domain, and range.